In this video, we are going to extend the AM-GM inequality, that is AM-GM-HM inequality. If you have not watched our two videos on AM-GM inequality, I recommend you to watch them first. Links are in the description. We shall also prove the inequality which is popularly known as Nesbit's inequality, that can be proved by cleverly using AM-HM inequality. And finally, we will see a very useful strategy, reverse thinking. So you have very good reasons to stay with me till the end. AM-GM inequality gives us the arithmetic mean of some non-negative numbers is greater than or equal to their geometric mean. We can extend this to AM-GM-HM inequality. That means for positive numbers we have AM is greater than or equal to GM is greater than or equal to HM. And both the equalities hold if and only if all the numbers are equal. In other words, for positive numbers a1, a2 up to an, we have this inequality. We have already shared the proof of the first inequality, that is AM-GM inequality, in the previous videos. If we prove the second inequality that we call GM-HM inequality, then it will complete the proof of AM-GM-HM inequality. Interestingly, the GM-HM inequality is the direct application of AM-GM inequality. If we apply the AM-GM inequality on 1 over a1, 1 over a2 up to 1 over an, then we get this inequality. That is exactly what we wanted to prove. Thus we complete the proof of GM-HM inequality and hence of AM-GM-HM inequality. Before picking up the problems, I would like to get your attention on one of its particular case, that is AM-HM inequality. It is worth to mention this inequality separately. In fact, I would like to show its another but equivalent form which is more important and of good use. That is the product of sum of n positive numbers and the sum of their reciprocals is greater than or equal to n square. In other words, for positive numbers a1, a2 up to an, we have a1 plus a2 up to an into 1 over a1 plus 1 over a2 up to 1 over an is greater than or equal to n square. In fact, this inequality is so important that I would like to show you its couple of special cases for 2 and 3 numbers. For two positive numbers a and b, we have a plus b into 1 over a plus 1 over b is greater than or equal to 4. And similarly for 3 numbers, we can state this inequality. Now all is set to pick up the problems. Let's take the first problem. For positive a, b, c and d with a plus b plus c plus d is equal to 1, prove that the sum of these four ratios is greater than or equal to 2. Immediately it is not clear how we should start this problem, but once we notice that we are given the value of a plus b plus c plus d, we should give a try with AM-HM inequality. So we apply AM-HM inequality on 4 numbers that are the denominators of given ratios, and we get 8 times of a plus b plus c plus d into the sum of 4 given ratios is greater than or equal to 16, and after we use a plus b plus c plus d is equal to 1, we get the required inequality. This completes the solution. In this problem, we had a strong hint to use AM-HM inequality because we were given the sum of 4 numbers and we were asked to prove the inequality on the sum of their reciprocals. But it is not always clear which inequality is useful, and the more difficult is to pick up the right numbers on which we should apply the inequality. This point we have already discussed in detail in our video on AM-GM inequality part 2. The link is in the description. We have given AM-GM-HM inequality in detail in our book Algebra Volume 2. In our books, we have given all the theory in detail and lot of problems for practice with hints and then solutions. The links for the books are in the description. The next problem is quite interesting. In fact, it is popularly known as Nesbit's inequality. For positive a, b and c, prove that a over b plus c plus b over c plus a plus c over a plus b is greater than or equal to 3 over 2. Well, in this problem we are not given the sum of any numbers and frankly speaking, I do not have any clue how to start the solution. One thing I observed that there is a symmetry in LHS. So I am thinking to use this symmetry somehow. So my idea is to take some reversible steps and to reach somewhere which is obviously true or easy to prove. So by keeping symmetry in mind, let's add 1 in each ratio. And interestingly, we get something more familiar. Now the given inequality is equivalent to a plus b plus c into 1 over b plus c plus 1 over c plus a plus 1 over a plus b is greater than or equal to 9 over 2. Is this the true statement? If we rewrite this in this form, and 2a plus 2b plus 2c can be written as b plus c plus c plus a plus b, and thus we get that the product of sum of 3 positive numbers and the sum of their reciprocals is greater than or equal to 9, which is of course true by AM-HM inequality. And since all the steps were reversible, so this proves the required inequality, and this completes the proof. Well, this is a perfectly legitimate solution in mathematics, but if some of you are hesitating in accepting this solution of taking reversible steps, then they may put all this work behind the curtain and can simply present the solution in the forward direction. In that case, we have to start the solution by applying AM-HM inequality on the numbers b plus c, c plus a and a plus b. That gives this inequality. And we can simply follow the routine steps. Eventually, we reach the required inequality. That's it, we are done. But think for a moment, what would happen if I directly present this forward solution before you? You would obviously think, how can anyone in the world come up with these 3 magical numbers b plus c, c plus a and a plus b, on which AM-HM inequality would serve our purpose? Well, the answer lies in the reverse thinking that we have put behind the curtain. That is the beauty of problem solving. This happens in mathematics many times. We do some work in backward direction to get an idea and show only the forward approach. That makes others surprised and baffled. But you know in your heart that it is not the magic but the power of reverse thinking. That's it in this video. Next week I shall come with another exciting inequality, that is Cauchy-Schwarz inequality. Make sure you subscribe our channel if you don't want to miss such nice videos. Thank you for watching this video. See you next week.